Okay, we can start. So don't talk about the homework more. If you talk a little bit more, then I will feel even more sorry and sort of do meaningless things. Okay. Maybe I have to take a pill before coming to your lecture. Okay. Now, the next paper is actually not a required paper, but I wanted to mention a few things about vendor-managed inventory because I feel that it is an important topic. And so I am going to talk about that for a while. It may not be that long. So this is the paper by Fry, Kapuczynski, and Olsen, Fry et al., 2001. This is actually an interesting work because up to this point, vendor-managed inventory systems were mentioned in academic meetings as well as in practice meetings of Informs and other organizations. But there was never a mathematical model explaining how this is going to work. Actually, if you ask me, this paper has a lot of missing issues. And there are currently in the literature, there are a number of studies which are trying to fill those gaps. So even if we have this idea of vendor-managed inventory available, it's not very clear on how one is going to model the issue and capitalize the advantages that we have been mentioning. So what is the idea of VMI? Simply, let me explain the idea of VMI. Here you have a vendor, and you can consider this as a supplier. And here we have a retailer. And the demand that the retailer sees is random, stochastic demand. And what happens is that the usual way of operations is retailer orders the vendor, okay, so gives an order. This is sort of an information. So let me show this as the information flow, gives an order, and vendor actually supplies the retailer. So this is the physical flow, information flow, physical flow. Now, in these type of systems, of course, vendors and the agreement between retailer and vendor is very simple. The retailer says that this is the number of units that I want, and usually vendor puts some kind of a lead time and tries to fulfill that demand. And according to the contract that they have, if the demand is not fulfilled, probably the vendor is going to pay some penalty, but that penalty is not going to be that large in general because there are many different suppliers, retailers that the vendor is working with. So it's not going to be that much important for the vendor. And moreover, vendor cannot anticipate the size of the order which is coming from the retailer. And as a result, the uncertainty, the bullwhip effect, actually makes things a lot of worse. This is the traditional way of operating. So instead of this, what the vendor-managed inventory does is very simple. We don't have any relation like this. The vendor simply actually sees the operations and sends or ships according to the demand which is occurring. Retailer is passive with respect to the giving orders and giving information because the information is already available. So how is this possible technologically? The retailer may have point of sales data, and that data might be transmitted to the vendor immediately. This is what you have in auto industry actually. In the retailers, in the car dealers, when an automobile is sold, even if when you start to action actually, like to the action of sales to a customer, the supplier, which might be a distributor or the factory actually, turns out that they would know that this specific automobile is sold. Okay? So in that respect, the information flow is available, And worst comes worse, if it's not available, at the end of each day you can report it to the supplier. So what happens here is that the information is available. Okay, the information is available, and the vendor simply manages the retailer's inventory. Now, of course, there are a number of questions that should be raised. Why should the retailer accept this offer? So that it means that there should be a contract in between these two entities in order to make sure that retailer is not losing anything. Okay? And why is the vendor going to accept this offer? The vendor is going to accept this offer because vendor usually gives production decisions as well. So it is going to give more sensible production decisions, taking this information into account. Okay? Rather than having once in a while some orders coming in, knowing the actual demand, following the pattern of the actual demand, the vendor can react in a more favorable way. So this is the advantage of work VMI. Of course, the key issue is the contract in between these two entities. And the contract, you never know what the contract would be. And it turns out that there are a number of instances where retailers might not be willing to cooperate, but they have to. In case of automobile dealership, this turns out to be the case. Now, at the old times, when the dealers were more independent, if you had a wealthy dealer, a large dealer, the dealer would be able to buy anything they want, anything he wants from the factory, and place it in the showroom. Whereas now, actually, the manufacturer is deciding on what to show there, which is usually creating less sales and more restrictions in a way. So the retailers are not going to be always happy with this agreement, unless, of course, you have a very good way of securing your previous profits. Okay.
Might there be a contract such that the vendor will pay for the inventories of the retailer?
Okay. Now that's okay. Now in the VMI, the question is, will the manufacturer pay for the inventory of the retailer? Now it turns out that in the contract, which is in between the supplier and the retailer, can be of various different types. Now, and one of the most important issues of discussion is who is going to pay for the inventory in the retailer. So there are two issues, actually. If this is sort of the timeline, and this is time 0 where, let's say, the product is at the retailer. So I'm following a single product. And so there are various different possibilities. And if this is the time that the product arrives at the retailer, and if this is the time that the product is sold, okay, now for the whole period of time, okay, the supplier can be responsible from the holding cost, or there would be a maximum time up to which the supplier is going to be responsible, then the retailer is going to be responsible. Or another way of the agreement can be, if the total holding cost is 100, 70% of it will be of the responsibility of the supplier, and 30% might be the responsibility of the dealer. So you have various different approaches that you can use. What is the meaning of that? The meaning is simply, if we're talking about 70%, 30%, if there are 10 automobiles in the dealer, the dealer only pays for the 3 of them. Okay, so that's the logic. And the others are not paid until the sales time. So there are various different ways of keeping up with this relationship. And in this paper, we have a different type of contract. That's one of the criticisms that I have for this paper, because it doesn't use this rich realm of possibilities, but it restricts itself to another policy, and I will talk about that policy. Okay, but this is the problem this is the VMI problem. Any questions on this? Okay, now next step. Now, in the paper, what they propose is, they propose a ZZ type policy. This is not something which is widely known. Okay, this is the name that they have given. So you are not going to see this ZZ type anywhere else. But basically, the policy is as follows. Now, there are 4 parameters which is agreed upon in between the retailer and the supplier. And these are the 4 parameters. Now, what this says is simply as follows. We have sort of periods. So the penalty, and these are the penalties that are going to be paid by the supplier to the retailer if certain conditions do not hold. Now, if at the end of the period, if the inventory level at the end after meeting the demand, okay, if the inventory level is below lowercase z, okay, per unit below, a penalty of B minus is paid by the supplier to the retailer. So if the inventory level is above capital Z, okay, so let me write capital Z like this, then a penalty is paid again by the supplier to the retailer for each unit above this capital level Z. So what does this mean? This means that the retailer, so this is retailer's inventory, would like to see its inventory in between 2 values. This is after meeting a demand in a given period. So if the inventory level is below this, a penalty is received by the retailer, and some money is received by the retailer. If it is above Z, some money is received again by the retailer. So remember the control charts in quality control? Oh, it's very similar to that. So if the inventory level is outside the limits of outside the band that we're talking about, a penalty is paid by the vendor. So although vendor is controlling the whole inventory, the vendor has to make sure that most of the time the inventory level is in between these 2 levels. If it exceeds, then some money is paid. Now, it seems to be very logical, of course. But the problem is, of course, how are you going to determine these parameters? Now, let me say the following. What happens if the supplier is going to determine the Z and lowercase z and capital Z? What will be the values of those? Okay, well, it's even worse. Minus infinity for little z and infinity for capital Z. Okay? How about the vendor? How about the retailer? If the retailer is going to set these numbers,
set them equal to each other?
Yes, and what will be the value? 0. Because if it is negative, what is the meaning of that? It means that some customers are not satisfied. If it is positive, you have, after demand, you have some left in the inventory every day. So you can see that both of them, if the retailer sets the lowercase z will equal to capital Z, and that will be equal to 0. This is the perfect case for the retailer. And if everything is set by the supplier, then Z is going to be minus infinity, and capital Z will be plus infinity. Okay? So now, of course, there is a bargaining going on. And what they do is they handshake at a certain point where both of them are satisfied. But still, you can see that this is not an easy type of a handshake. I mean, how are you going to do that with the auto dealers and so on and so forth? And that's the reason why, this is my criticism, this is not a very realistic policy. It looks very nice actually, but when it comes to actually setting it, it is going to have a lot of problems. But idea is okay. Of course, these penalties are not very easy to set as well. Okay, any questions on the policy? So what they are going to do is they are going to assume that this is a policy which is available, and they are going to optimize the operations of the supplier given this policy. Okay? And of course the vendor, the retailer is going to be happy because basically retailer would be paying inventory holding cost and penalty backorder costs, but would be receiving some penalties if these limits are exceeded. Okay? So there will be some returns for the retailer. So now, after this point, we assume that the retailer has satisfied its objective function, and there is nothing to optimize in the retailer's objective function, because once all these parameters are set with the contract, retailer simply receives goods, pays for the inventory cost, pays for the backorder cost, but receives some penalty costs. Okay? So there is no optimization for the retailer, whereas for the vendor, now we have to figure out how am I going to make production and deliveries to the retailer so that I will minimize my total costs. Okay, so that's the problem for the vendor. Any questions on this? So let me write this. So for the vendor, retailer, so once parameters of the contract are set, no further decisions. Okay? I mean, there are no further decisions because now all the stocking decisions are going to be made by the vendor. And on the other hand, supplier or vendor is going to decide on production quantities and delivery quantities. Every period there will be a certain delivery, and supplier is going to decide on that. Okay. Any questions on this? Okay. Now let's examine the order of events. Now this is, of course, very important, and you have realized that in your simulations as well, I suppose. The order of events is extremely important because basically you have to understand which follows the other, otherwise you are going to have meaningless results if the order that you make is not correct. Okay, so in this case the order of events is as follows. In one, supplier examines the inventory level of the retailer and decide the shipment quantity plus the outsourced quantity. I'm going to explain this, what we mean by outsourced quantity. We assume that the supplier has some kind of a capacity limit, okay? So, because if we don't assume capacity limitation, then there is no problem of the supplier in reacting the demand of the retailer. So we assume some capacity limit, and if the capacity limit is exceeded with respect to production, then outsourcing is a possibility, but but supplier pays more money for that. So every period, I look at the inventory level of the retailer and decide on the total quantity to ship. Some of them would be coming from my own sources. I call that shipment. And some of them is going to come from the other factory. I call it the outsourced quantity. And secondly, I assume that we have a negligible lead time. So after negligible lead time, everything is going to arrive at the retailer. Number 3, the retailer is going to face the demand. And finally, number 4, okay, penalty costs, if any, are incurred for the vendor. Again, you can see that we first make shipment, we first observe, decide on the shipment quantity, shipment and outsource quantity, then there is a negligible lead time, so it arrives immediately, okay? Then you have retailer facing the demand, and then the penalty costs are incurred. And then next period, we start again. So here, a few key things again. Supplier examines the inventory level, which means that the inventory level information is available. Okay? Now, this is the benefit that the supplier is getting out of all this agreement, because now supplier will be able to know the demand of the retailer, and the bullwhip effect is not going to be felt in the decisions. Okay, because basically follows the demand and reacts to that demand. Okay. Now, supplier, of course, if you remember the EOQ, for example, or EPQ, economic production quantity, manufactures in cycles. And let's call that cycle T. So what's the meaning of this? So this is the time horizon. These are periods, let's say 0, 1, 2, and then we have T minus 1 T. So production is made here, etc. So you have a production which is realized once in every T periods. Okay? So, and this is basically what is done in practice. Usually, to describe this is as follows. The supplier has limited capacity, okay? And in each time period, it works for a number of retailers, but not all of them. So we'll be manufacturing something else for another retailer. We'll be manufacturing another product for maybe the same retailer. But basically, it has some kind of a capacity that allocates to different retailers. And that's the reason why it does manufacturing once every T periods. Okay, this looks similar to the exam question, but it's not, actually. It just has the same feeling. Okay, and of course, what happens is that every period, here a manufacturing is done, so what will happen is that the inventory level will, this is 0 and this is T minus 1. So the inventory level will be very high in the beginning. And every period, a certain quantity will be shipped. So the inventory level will go down. And at some point in time, of course, you will never outsource in these periods because outsourcing is more expensive. So you will always satisfy from the demand. But once you are out of stock and you have to deliver certain quantity because of the agreement, then you start using outsourcing here. And you outsource, and then you have a huge inventory, and then you decrease the depleted inventory every period. So this is the typical inventory situation in the supplier for this item. So you start with very large inventory, then you ship a certain quantity, you ship again, you make another shipment, so on and so forth. Of course, what will be the quantity that you ship? There will be an ideal order up to point for this part, and so the difference is simply going to be the demand. Now, tell me the following. The order up to point that you compute is going to be different. Will it be different in case that you know that you are going to use outsourcing versus you are not using outsourcing? Will it be different? Yes. Well, yeah, of course, the way that I framed the problem, the answer should be yes. Okay, so what does this mean? This means that the item that you are getting is cheaper in value because you are manufacturing it. So the order up to point is going to reflect the economies of penalties that we were talking about, ZZ penalties, versus holding inventory costs. Okay, that you have above, and this is basically what you are trading off. So as the unit cost increases, of course, you will be less willing to send more because now the items are more expensive. So instead of buying an additional item from outsourcing additional item, you may prefer not to do that, and because of the expensiveness. So you can see that there will be two different order up to levels. One of them is going to be here. The other one is going to be in the case where you are using outsourcing. So this is what they compute actually. You have two different levels.
Should we compare the cost of holding inventory and outsourcing?
Okay. Now, holding inventory.
If it's greater than the unit cost of outsourcing, then
It cannot be. Because basically we know that if we manufacture, it is going to cost 1. If we outsource, it is going to cost 1.3. So the holding costs are going to be like that as well. So it means that I would always prefer to use my own factory's production than outsourcing, because outsourcing is more expensive. Okay, so this is actually the first theorem that they have. They simply say that I would never use outsourcing if inventory is available. Okay, that's the first theorem. Anyway, so basically this is the way that the supplier reacts to changes. Now, what is the supplier's objective function? Supplier's objective function is going to be something like this. So let me write that. So I'm going to have my Q, and well, this is a function of different things, so let me not write Q, but in general. So what I have is I'm going to have n from 0 to t minus 1. Okay, and inventory, IN. So IN is going to be, let me write it here, IN inventory at the, well, it is the inventory level. Actually, I don't need to write that. You can understand that. It's the inventory at the end of the period. So you charge some holding cost, plus you are going to charge some additional costs if you buy from outsourcing. So this is going to be ON. ON is the outsourced amount in period N. Okay? So what I'm assuming is that I am marginally taking into account the additional cost of outsourcing. So I'm not considering explicitly the cost of manufacturing, but this B0 is going to be the additional cost that you pay for outsourcing. So what does this mean? This means that if I gave the example 1.3, so this is going to be 0.3. Okay? So this is the additional cost that you pay. This is the outsourced quantity. Then I'm going to have two terms, which is going to be reflecting the penalty costs. So I will have B plus summation n from 0 to t minus 1. And when am I going to pay this B plus? If the total amount at the end of the period, so I'm going to have yn, the total amount that I bring the retail inventory. This is my decision variable, order up to point, but it is a function of n, of course. And so it will be yn minus dn. Okay, so this is the remaining amount which is left in the inventory, minus capital Z plus. So if this exceeds capital Z, I'm going to pay some penalty of B plus. Remember, this is written in my contract. Plus B minus, I'm going to have n from 0 to t minus 1. And I'm going to have this time, if the inventory level which is left is less than Z, lowercase z, then I'm going to pay some money. So this is lowercase c minus yn minus dn. Yes, and if this turns out to be positive, then I'm going to pay the other penalty cost. So let us see this again. Yn minus dn, dn is the demand, yn is the starting level, is going to be the inventory which is left. And that inventory left, if it is below z, lowercase c, then I'm going to pay this. And this is actually what it is doing. Okay, of course, now this function is nonlinear in which sense? You mean like this plus function? Of course. Now what we have is demand is stochastic. So we are going to take expected values. Yns are the decision variables. So these are the decision variables, Yns. And Ons are also decision variables. Note that the inventory On and Yn are going to be related to each other. In other words, you will either use your inventory in the previous period to satisfy your Yn, or Yn is going to be decided if you are going to outsource. Okay? So there is a relation between inventory in the supplier, the outsource amount, and the order up to amount that you bring the retailer. So the decision variables are, although they are related, Yns or n, and inventory is going to be sort of the outcome. Okay? Of course, what you have to do is you have to decide on the initial amount, the production amount. So the production amount is actually here, I0 is going to contain the production amount that you do in your system. And that is also going to be a decision variable. So all of them are related to each other, but basically this is the problem that you want to solve. You want to minimize your expected cost in this type of a system. And you can see that you can solve it with dynamic programming if you assume that this cycle is going to repeat itself and you only minimize the total costs in this cycle. You see, this is the cost in the manufacturing cycle, within the manufacturing cycle, and you have all these cycles following each other, but basically this is what you have. So you assume that it's the same thing. You know that it will be the same. There is no reason why to think that it is not going to be the same. Although there are some issues of concern there. You may end up with a lot of backorder and you may decide not to satisfy them. Okay? So here you have actually problems of those little sort, but they assume that this is the cost function and they minimize this using dynamic programming. Of course, to solve this dynamic programming is not easy because you have a large number of parameters and so on and so forth, and everything is stochastic. And in that respect, they used a method called EPA, infinitesimal perturbation analysis, and solved the problem using that method, although other methods can be used to solve this problem. One possible method to solve this problem is to use Markov decision processes if the distributions allow for that. MDP. Okay, Markov decision processes. If you have discrete demand distributions, of course you can utilize MDP if the state space is not that large. Okay, so this is what they solve, and then they talk a lot about how to set the ZZs for different parties, so on and so forth. But as I said, it's nice because it at least shows that then the VMI situation, so let me put this at the top. Now, given that the vendor is controlling the inventory of the retailer, under this stochastic demand situation, where there are certain penalties that are paid when you are under or above certain values, okay, you can optimize the problem for the vendor and find out YN values. Okay, so bottom line is that one, is this result. Okay, any questions on the result in general? So what are the things that are not done in a nice way in this paper? Number one, this optimization is good, but cycle optimization may not be sufficient in general if you have wild distributions. So this is number one criticism. Number two criticism is that this ZZ policy, although looks very nice, it's very hard to determine the parameters for. So ZZ policy is not really a practical policy to apply. Now instead, what you can do is you can do the following. Let's say that, okay, so now it's time to talk about that. By the way, I probably missed something, and that is what they do in the paper is they compare the results that they have here with this policy to a regular retail managed inventory system. Retail managed inventory system is the traditional system where you give orders as you did before, and the manufacturer tries to satisfy that. So a cost comparison is made for the supply chain totals, of course, and then it was shown that this policy is much better. Of course, it is going to be much better because it is using information for both sides. Now, the issue is the following. So when we look at the total supply chain cost, this is always VMI will always be better. There is no doubt about it, okay? Because basically what the supplier is using is the information which is available. So the variability that it sees is less. So if you correctly set Z values, ZZ values, note that all of these, when you look at in the supply chain context, will be simply transfer costs. It's not going to change the total cost because one side will pay, the other side will get it. It will be within the supply chain. So VMI will always be better. But the problem is, of course, when you look at the individual costs, is it going to be like that? In other words, we have before VMI, the retailer had some kind of a service level and some kind of a expected total cost. This is before VMI, and the supplier had similarly some expected total cost. Okay. Now the issue is what happens after VMI and and the total increases, okay, it means that somebody is benefiting from that. But given this specific policy, we don't know whether the retailer is now having a better expected total cost, better service level, or not. We don't know that. As a chain, everything is getting better. That's correct. But it might be the case that the supplier might have tripled its expected, well, might have decreased the expected total cost in a wild way, but the retailer's expected total cost have increased. So given this situation, one might think of modeling the same VMI problem in a different way. Why not have a VMI structure where you restrict the retailer's total cost and service level in terms of what it would have been if there was no VMI? In other words, put some constraints on the expected total cost. So simply this is to say the expected total cost of the retailer should not exceed what it was before. The service level of the retailer, the fill rate of the retailer should be at least as good as what it was before. Okay? So these two constraints, if you have these two constraints and solve the supplier problem now, okay, this is going to be sort of a much more reasonable problem to solve. Of course, when you have ZZ, you cannot do that because those ZZs are going to give that conditions. But in general, this is what is missing in this paper, and this ZZ is too restrictive for that.
Well, what would be the expected total cost of the system in that case compared to the...
Okay, in this case you mean?
The case you said.
Okay, expected total cost before VMI would be the individual expected total costs of different parties. Like if you don't have VMI, how is the retailer going to, the retailer is going to give an order every period. Probably it is going to utilize an order up to policy. Okay, every period, give an order. And the supplier has to satisfy that every period. So this means that it will outsource depending on the size of the order coming in. But every period, it may outsource. Or if it is available, of course, it is going to supply it from the inventory. So when you add up the costs of these two systems, it is going to be the total cost of the supply chain before VMI. Now, after VMI, you have some kind of a collaboration which comes with these ZZs. And of course, the total cost that the system is going to incur as the supplier knows the inventory levels, the demand levels, so on and so forth, is always going to be less. The total.
I want to compare the following two cases. The cases, the first one is after VMI. In this case, vendor is deciding everything.
Yeah. Okay, so this is the cost that you have, one portion. And then you have the retailer's cost adding at the top of this. Yeah.
And the second case is the one you mentioned. We put constraints such that the service level will be no less than the.
Okay. Yeah. Okay. Now that is what I was telling. Like as further thing that you can do, looking at this paper, you can simply put these constraints into the system and solve. Again, a VMI type problem, not with ZZs, but now the supplier is going to minimize the total cost of operation, which is again similar. You have outsourced amounts, you have inventories, plus at the top of that, you are going to have some constraints. So if you solve that problem, now you might be able to find a solution or not, depending on the situation, of course. So it's not always clear at that point that you will be able to find a better solution. Because the retailer's starting desires might be very high. And at that point, then the supplier may not be able to fulfill that. Actually, there are certain results, and if you are interested, I can send that. It's still, it's something that I have been doing with another colleague of mine, and it's almost, well, ready for publication. It is still under review. But what we have done is actually we have shown that there are certain situations where VMI is not going to be a reasonable choice. Okay, if you do restrictions of this sort, actually. In other words, it's not going to be reasonable because it's not going to have the effect that you really want it to have. So the manufacturer will not be willing to participate in that kind of a VMI. Okay? But here, on the other hand, you have only one-sided problem. Given certain z's and capital Z, lowercase c, VMI is if you accept VMI all the time because we don't consider what's happening in the retailer. Okay. Now, the main issue here is that we have the information issues coming in. Now, the key is by giving this penalty and compiling with this lowercase c, uppercase c, the supplier gets the information. So what we looked for is whether, so the benefits are coming from the information, knowing the information. What we looked in the paper is the benefits beyond information. We said that, okay, let's say that they are going to share all the information. Okay? Even before a VMI as well. So they can do their operations when they know all the information. But it turns out that VMI may bring additional benefits from the operations, okay, even if you have full information available from the beginning. So this is what we showed there, actually. But this is sort of like a nice paper because most of the things that we did is very similar to Fry et al. But we tried to basically eliminate some disadvantages of having a policy like this, which is a very difficult policy to decide on. Okay, any questions on this? So again, this paper was not for, I mean, I didn't require you to read this paper. It was recommended, don't forget. So I am probably not going to ask any questions from this. Okay, but I want you to learn the idea of vendor managed inventory. Okay, any questions? I'll see you on Thursday.